Up until now, we've been covering inorganic chemistry. So these are the molecules at the bottom: carbonate ion, nitrate ion, ammonia, and water. And they're pretty simple. Above, we can see these molecules are hydrocarbons with a lot more atoms. So there's a different process for naming organic molecules. Organic molecules have a lot more atoms, but the majority are going to be hydrocarbon. So this is the line angle drawing. Remember, those are carbons and hydrogens, but any differences like the bromine or the fluorine, or when there's a double bond, those are added into the line angle drawing. And this long name at the bottom is the name of this organic compound. So what happens is the parts of the organic compound are named, and putting those parts together gives you the overall name, which is a big long name because it's a big long structure. So this is the IUPAC rules. That stands for the International Union of Pure and Applied Chemists, and they designate rules for writing names and structures of organic compounds. Organic naming starts with prefixes that indicate the number of carbons in a hydrocarbon. We've seen these before. So that's meth, eth, prop are the first four in the alkanes. That's when you have all single bonds in a hydrocarbon. Other prefixes that go up to 10 carbons: pent, hex, hept, oct, none, and dec. We'll start with when you're given a structure of an organic compound and you need to write the name. This is 1, 2, 3, 4, 5, 6 carbons, and the prefix is hex. They're all single bonds, so that means it's an alkane with the name ending ane. So this is called N-hexane. It's normal straight chain hexane.
First thing you have to do is find the longest continuous chain of carbons. So the continuous chain is a single path from one end carbon to the other end carbon. It has to pass through every carbon atom without going back, and this could be a straight line. This would be the longest continuous chain, which is 6 carbons either left to right or right to left. Hexane, but there's some bends in this. So there's bend, bend, and a bend. And the reason is because every single carbon can have rotation around the carbon. And so though this was a straight chain, this now is still going to be a longest continuous chain of 1, 2, 3, 4, 5, 6 carbons, but it doesn't have to be a straight line. So this longest continuous chain does not have to be a straight line. And so this can be the case for this example, which is due to just rotation around these carbon atoms, or it can be due to branching. So it's usually going to be due to branching off the main carbon chain. These are some examples where you are trying to find the longest continuous chain. In this first one, if you just count from left to right, 1, 2, 3, 4, 5, 6, 7, 8, that would be left to right or right to left. This would have 8 carbons, okay? Which means that this here is a branch. That is a carbon that is connected to, this is a bond, connected to the main chain. And so you wouldn't count 1, 2, 3, 4, 5 because that would be less than the 8. So you need the maximum number of carbons for the longest continuous chain. For the next one, if you were to count left to right, this would be 1, 2, 3, 4, 5, 6. But if you consider 1, 2, 3, 4, 5, 6, 7, 8, well, now you have a longer possibility. You can still have 8 carbons this way. And what this leaves is this is a branch off the main chain. The reason why this is counting here 8 carbons, starting with the number 1 and counting this direction, is because you want your number 1, your lowest carbon, should be closest to the end where there is the branch. So start your numbering from the end that's closest to the branch. For this next example, if you were to just look at this and count straight across, you'd have 1, 2, 3, 4, 5 carbons. But if you count from the right side, 1, 2, 3, 4, 5, and look and see, oh wait, I can continue down for a continuous chain. So this is 1, 2, 3, 4, 5, 6, 7, 8. You would end up with 8 carbons, and this ends up being a branch off that main chain when it's not part of the continuation. And you want that branch to be having the lowest possible number. So this is, instead of 1, 2, 3, 4, 5, 6, 7, 8, I'll show you what happens if you number it this direction. 1, 2, 3, 4, 5, 6, 7, 8. So this branch is going to be off carbon 4 if you number it from right to left. If you're numbering it this direction, or if you number it with this branch on carbon 5, if you're going in this direction. So the problem is you want that branch to have the lowest possible number. So to have that lower possible number, the choice is to go with this branch off carbon number 4, which is numbering at 1, 2, 3, 4, 5, 6, 7, and 8.
When you're given the structure of an organic molecule and you want to write the chemical name, you first find the longest continuous chain of carbon atoms, and that's going to be the parent chain. Then you number those carbons in that parent chain, either from left to right or right to left, starting from the end that's closest to a branch.
In this example, I can number this from left to right in blue, 1, 2, 3, 4, and have this as a branch. Or I can number this from right to left in red, 1, 2, 3, 4. So if this is the branch, for the branch to have the lowest possible number, it is going to be on carbon 2 if it's numbered in the red, or it is branching on carbon 3 if it's numbered in the blue. So you want the branch to have the lowest possible number. So I'm going to choose this numbering from right to left. So you want the lowest possible number for the branch. And it's going to be true about the lowest possible number for the branch, or when we're looking at functional groups, or a double bond or triple bond. Branch is on carbon number 2. And what this means is this is a branch that is a 1 carbon long branch. So this is a 1 carbon long branch off the parent chain, carbon number 2. And the parent chain length is 4 carbons. Okay, so when you are thinking about the parent chain, that length of the parent chain, how long it is, will give you the prefix, which is 4 carbon prefix is bute. Okay, so that bute is all single bonds between those parents, so this would be butane, would be the name of the parent chain. And then the 1 carbon branch off the parent chain, this 1 carbon length is going to be the prefix meth. Meth means 1 carbon. And that is, the branch has a name ending, not ANE, but YL. So this YL signifies the name ending for a branch. And so that location of it on carbon number 2 goes in the front of the branch, so 2 as the number, and then that's attached to the name with a dash. Okay, so and then putting these together, this is 2-methyl is the name of the branch, and then putting it together with the parent name is going to be butane. In this example, the longest continuous chain looks like it's going to be straight across left to right with 5 carbons. So this is a 5 carbon parent chain. And then the decision is whether to number from left to right, which would be 1, 2, 3, 4, 5, or from right to left, this way, which would be 1, 2, 3, 4, 5. So there's going to be two branches. So if I'm numbering this from right to left in red, this would mean that the branches are on carbon number 2, this one, and branching off carbon number 3, this one. So that's the choice, is to number it from right to left to give those branches the lowest possible numbers, which are 2 and 3, compared to being 3 and 4 if it was numbered in blue. So this is the parent, 5-carbon parent, which would have the prefix pent. And for the all single bonds, this would be the name ending ane. The individual branch, each branch has 1 carbon. So it's a 1-carbon long branch, this one and this one. So that means the prefix is meth. Okay? For the branch name ending, you add on the YL. And there's 2 branches. So there's a 2-methyl branch, that's this one. And then there's another branch that has the location that's different, dash 3-methyl. There's a different location. Okay, and then those branches are at the beginning of the name, and the end of the name you add on the parent name, which is pentane. So that's what I meant about putting these parts together of an organic molecule. Those parts of the molecule become parts of the name, and they all just get stuck together, and you get one long name.